Hello students, welcome to Inside Physics. Today we will see what is a crystal structure and what are the terms which are called space lattice and basis regarding this crystal structure. The study of crystal structures is called crystallography, and why we are studying the structure of a crystal means it has a unique relation with the properties of the crystals. So nowadays solids are called crystals, and we know that crystals are having a definite shape, a periodic arrangement of atoms. So it is a regular definite shape, and the whole structure together is forming a periodic arrangement. And how it is called, and there is a term called space lattice. We will see the importance of space lattice. So a lattice point is a point where the atom is supposed to be existing inside the crystal structure. So if you take the structure of a crystal, something like copper, iron or gold, silver, these are all the metals which have a solid crystal structure. So inside that, if there is a point supposed to be called as a lattice point, this is the point where an atom is supposed to be located inside the crystal structures. So the periodic arrangement of the lattice points or creates an environment which is called a space lattice. So what is a space? Space is a three-dimensional array of a particular structure. So if you understand this, lattice points are arranged in a three-dimensional way, and this structure, you can see these are all taken to this diagram. So you can understand the lattice points how they are arranged, and you can also see the lattice planes. So if all the lattice points are arranged in a sequential way, that means the distance between each lattice point is same, and the neighbors which are called the neighbor atoms is exactly look like a similar structure. The atom is same as that of the neighbor atom. So in a monoatomic crystals, the neighbor atoms are same. So in this way we can create an environment and study the crystal structure. Observe this, you can zoom it if you want to have a closer look. See, this is one plane and this is the second plane. These are called lattice planes. The four planes you can see 1, 2, 3, 4 arranged just like in a three-dimensional view, one behind the other. So these black spots are called lattice points. Okay, so a cell which is like, see, this is a unit cell. So a unit cell is nothing but a small arrangement with which we can repeat that arrangement and build the crystal structure is called unit cell. So this is three-dimensional lattice space, and see these are the lattice points, these black spots, and the lines connecting all the lattice points are called lattice lines. So why we are actually considering this geometrical structure means this is an assumption on which we are developing the crystal structure, and understanding the structure gives a advantage of understanding the properties also. So that is why this is all an assumption. So the space lattice and the lattice points, so this assumption gives us a clear picture of how the crystal structure will be, and the crystal structure can be understood better. So with this geometrical representation with what we are assuming. So how to create a space environment, a space lattice? there are some translations of lattice point. There is a lattice point here. So this is translated to another point, okay, and this again is translated to another point with same distance. So this translation to same distant points is called row points or lattice row. So this is, if you say translation 1 in the sideways, it creates a lattice point row. And the second translation, if you, it is called a planar movement. So lattice planes which are created in the planes. So if you translate this lattice point in this direction, so these points are all lie in the same plane, but the direction is different. This translation is second translation, and see, this will create a plane that is called a lattice plane. All the points are lying. If you consider this as x-axis and this as y-axis, this is considered as a lattice plane. And this is translation 2. And translation 3. How to get the translation 3 means, this translation 3 is into the space. That means you cannot show it on the board, but the direction will be like this. This is out of the board or into the board. What this lattice point is moved out of the board with the same distance. If this is the distance between two lattice points, this distance is moved or into the board. That I cannot show. Here I can show in a better way. See, this is moved towards this plane and that plane. The distance is same between all the lattice points. So these are the third translation creates space lattice. A space is an environment around the lattice point. Okay. So if you move in a direction, in a particular direction in a crystal, the environment will change, but the atoms are same and the distance between the atoms is same, and you can see all the neighbor atoms are pretty identical with each other. So this is called space lattice. So what we are going to estimate with this space lattice is the relation. This gives the relation with the properties of the crystals. So by understanding the properties of crystals, we easily identify the applications of that crystals for which we can use the crystal. So then second term in this is basis. Second important definition is basis. What is a basis? It is a group of atoms. It is a group of atoms surrounding the lattice point with which the lattice structure is built. If it is a monoatomic crystal like iron or copper, silver, gold, these are the monoatomic, creates the monoatomic space lattice. So there is a single atom, and if you go through all the crystal structure, all the similar, if you go through the iron crystal, all the iron atoms will be appearing in the all the lattice points. So if it is a diatomic crystal like NaCl or KCl, the basis, that means the number of atoms that surrounding the space lattice point is called the basis. The basis is 2. Here the group of atoms is 2. So here basis is 2 means sodium atom and chlorine. Sodium and chlorine forms the basis. So you can say that this sodium and chlorine, this is the basis. So if you go through the lattice structure, you can see a similar structure. If it is sodium here and chlorine besides there, and the atomic structure, then the repetition of atoms, sodium, chlorine, and again sodium, chlorine, like that, the structure will be repeated, and you can see a similar kind of structure in the entire crystal. So if it is a triatomic crystal like calcium difluoride, so the basis is 3. The number of atoms forming around the lattice point is 3. So basis plus lattice, this lattice plus basis, you can say simply space lattice, gives the entire crystal structure. This gives crystal structure. Okay, basis plus lattice gives crystal structure. So this space lattice is a geometrical arrangement, and the atoms participating in that arrangement forms the basis. So this is about these two terms which we must understand before going to actual crystal systems, which we are going to see in the next video. So here we will see some animation video to understand the crystal structure in a better way. Let us see.